Hello students, so here we are with the question 6 of the exercise 3.2 of the chapter pair of linear equations in two variables. So the question 6 is, given the linear equation 2x plus 3y minus 8 is equals to 0, write another linear equation in two variables such that the geometrical representation of the pair so formed is intersecting lines, parallel lines and coincidence lines. Before doing this question, we will consider two standard form of the linear equations, which are a1 plus into x plus b1 into y plus c1 is equal to 0, and the another pair of linear equation be a2x plus b2y plus c2 is equals to 0. Here we have considered two pair of linear equations which represent some line. So, the three conditions have been possible for these pair of linear equations. What are these three conditions? Let us see one by one. The first condition is the lines which have been represented by these pair of linear equations may be intersecting lines. So, what are intersecting lines? The lines which are meeting at some point. As these two lines are meeting at this point, so these lines are said to be intersecting lines. And for the lines to be intersecting, the conditions on the coefficients being provided by the linear equation is that a1 by a2 will not be equal to b1 by b2. Got it? So if a1 by a2 is not equal to b1 by b2, then those lines will be intersecting lines. Now coming to the another condition where the parallel lines are being provided, that is, the lines which have been represented by these pair of linear equations are parallel to each other. These lines are obviously the inconsistent lines, that is, we cannot find the solution for these lines as they are parallel to each other. So the condition on the coefficients of the pair of linear equations being provided is that a1 by a2 is equal to b1 by b2 but is not equal to c1 by c2. When such condition arises on the coefficients of the pair of linear equation, then such lines are said to be parallel lines. Got it? Now coming to the third situation in which the lines are being overlapped, that is, the one line lies over the another line. Then such lines are said to be coincident lines. And we can easily solve such pair of linear equations and are said to be consistent pair of equations. And in this case, that is in the case the lines to be coincident, the condition on the values of the coefficient of the linear equation is that a1 by a2 is equals to b1 by b2 is equals to c1 by c2. So we can say if the two pair of linear equations have been provided in such a way that the a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then such lines represented by those pair of linear equations will be coincident lines, that is, line one above the another. So this was all about the how to classify the lines. Now what have been asked in the question is to find the second linear equation in order to satisfy the lines to be intersecting, parallel and coincident. Now coming to the first part here, the first linear equation is 2x plus 3y minus 8 is equals to 0. And in this case, if we find the ratio of x by y, it comes out to be equal to 2 by 3. And for finding the linear equation, for the lines to be intersecting, the another line linear equation should be such that its ratio of x and y does not come to be equal to 2 by 3. Which means that we need to form such a linear equation that its value of coefficient of x and y is not equal to 2 and 3 respectively. So let us take a linear equation be x plus 2y minus 4 is equals to 0. We have assumed second linear equation in such a way that its value of the ratio of x by y is not equal to 2 by 3. And now if we find the ratio of these two pair of linear equations, then a1 by a2 is equal to 2, b1 by b2 is equal to 3 by 2, and c1 by c2 comes out to be equal to minus 8 by minus 4. Simplifying them, it will be 2, 3 by 2 and 2. As a1 by a2 is not equal to b1 by b2, so for such pair of linear equations, the line represented are intersecting lines. So means the condition for the lines to be intersecting has been fulfilled by our assumed second linear equation. So the second linear equation is right. Now coming to the second part, here we need to find the second linear equation such that the lines represented by the two pair of linear equations comes out to be the parallel lines. Now writing the first linear equation, that is 2x plus 3y minus 8 is equals to 0. Here the value of x by y comes out to be equal to 2 by 3. So in order to find the second linear equation such that the line comes out to be parallel to with respect to the line being represented by the first linear equation, the value of the coefficients of x and y of the second linear equation assumed should be such that their value comes out to be equal to 2 and 3 respectively. We can either take the factors of 2 and 3, or we can take 2 and 3 values as it is for x and y. So taking as it is value, that is for x the coefficient will be 2 and for y the coefficient will be 3. And as we know, for the parallel lines, a1 by a2 is equal to b1 by b2, but they are not in return proportional to c1 by c2, which means that the value of the coefficient of the second linear equation should be such that c1 by c2 does not comes out to be equal to 2 by 3. So let us take the value of c2 be minus 4. Now we will see whether or not the second linear equation is right. So taking the ratio of a1 by a2, it comes out to be equal to 2 by 2. b1 by b2 comes out to be 3 by 3 and c1 by c2 comes out to be minus 8 by minus 4. Simplifying them, 1, 1 and 2. That is a1 by a2 is equals to b1 by b2 but not equal to c1 by c2. As the constraint on the lines to be the parallel have been satisfied, which means that the second equation being assumed is appropriate one. So now coming to this third part, here it's been given that the lines should be coincident one. Let us write the first linear equation, 2x plus 3y minus 8 is equals to 0. Now we know that the coincident lines have their pair of linear equations such that a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Or we can say in the other way that a2, b2 and c2 are the factors of a1, b2 and c1 respectively. That is, a2, b2, c2 may be the factors, or we can say when some number is being multiplied by a1, b1 and c1 respectively, then they form the numbers a2, b2 and c2. So let us say the first linear equation being multiplied by a number 2. We can take any multiple, be it 2, 3, 4, 5. Depending on us, we can take any factor. So multiplying them, we can form another linear equation, that is 4x plus 6y minus 16 is equal to 0. Now writing the ratios 2 by 4, 3 by 6 and minus 8 by minus 16, simplifying them, it will be 1 by 2, 1 by 2 and 1 by 2. That is A1 by A2 is equal to B1 by B2, which in turn is equal to C1 by C2. So the condition for the lines to be coincident has been satisfied, which means that the pair of linear equation represent the coincident lines. So our assumption for the second equation for third part is also appropriate one. So this was all about the question 6. I hope this question is clear to all of you.